Hi, welcome to LeetCode. In this, we'll discuss LeetCode problem 3443, maximum Manhattan distance after k changes. So you are given a string S consisting of the character N, S, E or W. So N means it will move north by 1 unit, S means move south by 1 unit, E for east and W for west. Okay. So initially you are at the origin 0, 0 and you can change at most k characters to any of the 4 direction. So find the maximum Manhattan distance from the origin that can be achieved at any time while performing the movements in the order. So we all know that what is Manhattan distance. So if there is suppose x1, y1, one point, and another point is x2, y2, the Manhattan distance will be absolute value difference of x1 minus x2 plus absolute value of y minus y2. Got it? So this will be the Manhattan distance. So we have to actually maximize this Manhattan distance. So what actually we can do? We can actually change at most k character in the string S any direction, like north to south, east, west, any. Then south to north, east, west, any. In this actually I can actually change any character to any other direction. So we have to maximize the Manhattan distance any point of time. Like it doesn't matter that in the final distance, whatever the actual final Manhattan distance or the final point, that we have to maximize. Not, it is not. We have to maximize in between also. Like what? So currently, finally, we are starting from here. Then actually somehow I go to this S2. Then actually finally we are ended here S3. But suppose we are actually got the maximum distance at S2, suppose. So we have to actually maximize this, right? So now go to the example 1. So the string S is north, west, south, east, and we can change actually maximum one character, k is equal to 1. So how actually maximize? So suppose I choose this north to south. Okay. So first of all, understand that which character actually change to which direction. Okay, north is only possible to change south. Why? Because and south is only changed to north, east can only change to west, and west can only change to east. Now, if I have to maximize the Manhattan distance, like if I change to suppose north to east, okay, then suppose we actually have north east. Okay, this is our input string S. So I have changed this to east. So I have changed this north to east. So now what will be the distance? So first will be really 0, 0, then it will go to 1 east, so 1, 0, then it will go to 2, 2, 0. So what is the Manhattan distance after all? 2 plus 0, it is ultimately Manhattan distance is 2. Okay, suppose I change to this north to south. So this is the input string any. I have changed this to south and east. Then what will be the distance? Starting from 0, 0, south will be minus 1, 0, and then east. So south will be this. This will be what? This will be 0, minus 1, and then it will be 1, minus 1. So what is the distance or Manhattan distance of this? 1 plus 1, ultimately 2. Got it? Why it is actually doesn't matter. Actually, what actually are trying to do? Like we actually maximize this south distance. If I convert this north to south, then what are we doing? We're actually trying to go to the all north to south. Then actually we can actually increase the depth or the distance of the point. So if I convert to north to east, then actually it may be possible that another east west can come. This actually can actually decrease the effect. So that's why if I try to move all the north to south, then actually it is ultimately increasing the total depth. Now also it increases the Manhattan distance also, right? So it is clear for north to south. Similar for all other cases also it will be same. So north to south, south will be changed to north, or east can be changed to west, and west can be changed to east. Okay. Now how can actually maximize the depth? Okay, so if I convert all north to south and all east to west, then also we can actually increase the distance. How? Because what you're trying to do, we are trying to do that this is our north and this is our south and this is our east and this is our west. So we're actually trying to go to this direction. We are trying to sorry, not this direction. We are trying to, north is converting to south, so we are trying to this distance, and east to west, so this distance. So ultimately we are trying to go to this direction, right? We're trying to as much as possible this distance, follow this path, go to this as much as possible to go to the south, and as much as possible to go to the west. Okay, in this we can actually increase the distance. Similarly, what actually can do, we can actually convert all south to north. Whatever actually south or direction I'll try to convert this north, and whatever actually the west actually I'll try to convert this to east. Then actually this path actually also increase our distance, right? Then actually what actually we can do, we can actually convert all north to south and convert all west to east. Then actually we will follow this path. This actually increase our Manhattan distance, right? Similarly, this path is possible when actually we are trying to convert all east to west and all south to north. Then actually we follow this path. Clear? So 4 combination actually possible that actually we can actually increase our Manhattan distance. So case 1 is possible, convert all north to south, all east to west, right? Then case 2 is convert all north to south and convert all west to east, right? This is case 2. Next case is possible, case 3, that is convert all south to north and all east to west. And case 4 will be what? Try to convert all south to north and west to east. So out of these 4 combination, I will try to I can actually change almost at most k character. So I will actually apply at most k character that actually I can actually convert north to south or east to west. Okay. So after whatever actually string actually I have, so suppose this will give string 1, this will give string 2, this will give string 3, and this will give string 4. So out of this string 4 string, I will check that which string actually have the maximum Manhattan distance. So I can actually call a helper function that will give the maximum Manhattan distance. Whatever actually input string actually I can actually pass. Got it? The logic is clear. How you are getting actually the maximum Manhattan distance? How can you maximize this? So try to as much as north, as much as east. Similarly, for try to go as much as south, as much as go east. Then try to go as much as south and as much as west. Got it? This 4 direction is clear. So now go to the code. So first of all, I will find out the creating 4 string I have to create. So initially I have taken a temporary string. Initially that is similar to the same as string s, input string s. Now for this case 1, I am trying to convert all north to south and all east to west. And how many times I can do? Maximum k times. So k is initially is to x. Okay. Now I will check that the current character that actually I have in the temporary string, that is north. Then actually I can actually try to convert this to south, but it is depend on that is there any number of operations left or not. So k should be greater than 0. Then actually I can actually only convert. So if I able to convert, then actually I will store this south direction s at the character index I, and also decrease the 1 operation. Similarly, for if I can also convert this east to west, so I will try to check that if the current character is east, then if and also the k we actually number of operations we can actually do. So I will convert this to west and store it into the index I, and similarly by k minus minus. Okay, after converting this operation all north to south and all east to west, I will check that what is the maximum Manhattan distance I can actually get for this string. Okay, I will store into the answer variable. Again, I am starting from similar way. I am starting again, the temporary will be the string will be the same as the input string s, and k will be x. So now in this situation, in this case, I am trying to convert all north to south and all west to east. Similarly, I have converted this. Check this. north to south and west to east. Got it? And similarly, I am calling this for this direction or this string, what is the maximum Manhattan distance I can actually achieve. So that will actually store into the answer variable. Now, two cases still left, one for south to north and east to west, and another case is for south to north and west to east. Got it? Now, how actually getting the Manhattan distance, maximum Manhattan distance? So I will get the input string that actually give us the direction of the current next move or the current move. So our initially the x and y coordinate will be 0, 0, and if the current direction is north in, so that will actually increase out the y plus plus, else if it is south then actually y minus minus, if it is in east, so that will be x plus plus, else if it is west, so then actually x minus minus. So after this move, whatever actually the Manhattan distance, so absolute value of x plus absolute value of y, so I will store this into the maximum variable. So this will actually store the maximum at any point of time, what is the maximum Manhattan distance I can actually achieve. So I will return at the end. Got it? So in this I actually check all the possible combination, then actually return the answer, final answer, return answer. Got it? So this will take the maximum big of n time. So actually I am first actually trying to convert all combination, then actually for each whatever the direction string actually I got, that actually on basis of that string we are trying to find the maximum Manhattan distance. So that's the time will be in big of n. Got it? So if you like the exercises, please like the video. If you're not yet subscribed, please subscribe the channel. Thank you.